All right, let's take a look at another simplifying of a radical. This is just a square root, your run-of-the-mill square root. And we've said before, under the square root is a product. So I can separate the product into all of its parts, each with its own radical, right? So this could be the square root of 32 times the square root of x minus 2 to the fourth power. Now on a previous problem, or if this is the first time you're hearing this, we talked about how if you have a power under a radical, if the exponent is larger than the degree of the radical, you're going to be able to pull some of those out. Namely, this is a square root. This is raised to the fourth power. So the fourth power is a perfect square. Any even degree of an exponent of a binomial has a perfect square root, okay? Just as a quick little aside, if you had x to the fourth, the square root of just x to the fourth, okay, that's x to the fourth to the 1/2 power, isn't it? Radicals can be written as fractional exponents. So x to the fourth to the 1/2 power, if I multiply these, 4 times 1/2 is 2, so we get x squared. So when we take the square root, and specifically the square root of an even power, we just take half of it, right? So when we look at this, we have x minus 2 to the fourth power. It's this entire base raised to the fourth power. Take half of 4. That's going to be x minus 2 squared. If it was a 6, this would be a 3. If it was a 7, we'd have to do a little bit more legwork. We have an example of what that might look like here involving a cube root. Go back and take a look at that video. Okay, now we haven't forgot about the 32. Does the 32 have any perfect square factors? Yes, it does. 16 is one of its perfect square factors. The square root of 16 is 4. So because I pulled this out of the radical already, I pulled this square root of 16 out of the radical, I still have this square root of 2 as part of my final answer.